Testing 1, 2, 3. Testing 1, 2, 3. Step out the way, guys. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is Dave. We're teaching Python here. Today, guys, we are on episode 6, the final episode of the season. I thought it was episode 5. I lost track somewhere in there. And, I think since episode 3, I lost track of what day it was. So that means that this is actually episode 6 now, not 5. And that means it's our final episode of this season. So we kind of have to get this game working. Right now, it already works pretty well, as I recall. Let's go through it real quick and figure out where we are in the game. We have a protagonist. We have our items are all classes now. That's cool. As I recall, they're not really effective classes, though. I'm not sure how that I can fix that. I forgot what the problem was. We had some kind of problem with that. Oh, we have turn attack and turn defend and turn item. These need to be attributes of the player, not of the not just loose functions. The player object is kind of unused right now. The protagonist object. It's not really that interesting. It has no methods. What else we got here? We have a turn item. We have create a new monster. We should have a monster object, not a create new monster thing. Take player turn. Okay, that should be like a part of the battle object. Monster turns. That's going to be part of the monster object. So right now we kind of are in a transitionary phase, guys. We've got, transitional phase. We've got a bunch of loose functions here. And a couple objects we're kind of building up. We're kind of building toward a more object-oriented design. We talked before about how, up to this point, we've been using typically what's called functional programming, which is we use functions and arguments, such as a game state or other arguments here, to sort of make these functions do their job correctly. Whereas in an object-oriented program, you tend to think of your program more as being created of discrete parts, and those parts each have responsibilities. So it's a little bit different. Instead of having all these loose functions, we have things kind of organized into pieces called objects. And you can define molds for those objects by creating what's called a class. So a class will allow you to manufacture many similar objects. You can think of it like a mold, basically. And when you define your classes, you can define things that are called attributes and methods. That would be your data and your operations. Right? And our very first stream ever for Intro to Python, in the season and every season, we talk about how every program consists of data and operations, right? Well, classes are the same way. Classes are kind of like little miniature programs, and they themselves have attributes, which are their data, and their methods, which are their operations, the things they can actually do. They have things that are about them, which are their attributes, and things they can do with those attributes and other things. What else we got here? Conclude lots of battle functions. We have go shopping to actually use the shop. We probably have like a shop object in the future. So instead of having this function here, go shopping, we're going to have a shop object, which might itself have an inventory and a sales clerk, and then have these things about it, right? Then it can do things like sell you stuff. How about that? So Faust says, I'm hesitant to say it's the hardest series of all time, like people do, but it's definitely not easy to get into, huh? Yeah, I totally agree with that latter opine. Dark Souls is really easy. Really, really easy franchise once you know how to play it. Right, that's the thing. You have to know how to play it first. And for a beginner, it's pretty tough to get into. Okay, and then we have the actual game. The actual game plays right here. So already we have talked last time about abstraction. What the hell does abstraction mean, right? It means that instead of writing your program from top to bottom, right? Like you do when you're a beginner. As a beginner, you write your programs from top to bottom typically, which makes a lot of sense. That's how programs flow. However, what we've done here is we have abstracted out the parts of our program, right? The parts that do individual jobs, and we've made them into functions. Lots and lots of functions. And what's cool about this is that it means that when you see a function by the name of do battle, you know it's about doing battle. That seems pretty obvious, right? Likewise, the conclude battle function, you know it's about finishing battle up. Right? Go shopping function, it means to go shopping, right? So you kind of know that about it. And what's really cool about that is that it allows us to make our actual program flow down here much simpler and easier to understand, right? You can see what's happening here very easily. We define a game state, which starts off as being empty. Then we make a protagonist for that game state using our class protagonist. And then we have a little while loop here. While the player is still alive, while the protagonist has more than 0 HP, right? Then he can choose to either fight or shop. And that's saved as his destination, either a fight or a shop. Let me say here, if the destination is fight, well then do battle. If it's shop, well then go shopping. Otherwise, if it's neither one of those two things, say you have to print either fight or shop. You have to choose one or the other, right? and then, do it again. So basically, it's an ongoing loop. As long as the protagonist is alive, as long as he has more than 0 HP, to loop over and over again, saying, do you want to fight, or do you want to go shopping? Right? If you go shopping, well, then you come back here later and it asks again, do you want to go fight or go shopping? And likewise, if you finish your fight, it'll ask you again. Right? Over and over and over and over again. And if you do finally get below 0 health, you drop out of the while loop and it says game over. Press enter to close. Right? So the actual game flow here is very simple. That's because we've abstracted away all the complexity. So the complexity happens here in things like do battle and in go shopping. And if you go back to do battle, let's go up there to do battle, right? Let's find that function. There's go shopping, there's conclude battle. Here's do battle. It's also very simple. But again, that's because we've abstracted away the complexity. So first of all, it creates a new monster, right? Which itself is its own function, which is kind of complex. Then it prints off, the monster's approaching, prints off how much HP he has and the player's HP. And then it says here, while both characters, the player and the monster, are still alive, loop forever. Say, take the player's turn, and then take the monster's turn, and then conclude battle. Right? So basically what I'm saying here is that we have abstracted the complexity away. Right? We started off with a very long, linear list of instructions for Python, right? A very long, top-to-bottom kind of program. What we've done instead, though, is we've made each individual part of the program itself simpler. Rather than it being one monolithic tower of code, we have broken it into little segments that we've kind of defined as functions. That we can kind of find your way through it, and you can kind of pick and choose as a programmer, how deeply you want to get invested in this rabbit hole of complexity. Right? So basically, programming is a very communal activity. You're going to be doing it usually with other programmers. And maybe if you're not going to do that, you might come back years later and try to pick up a program you wrote, a few years ago. So it becomes difficult sometimes to always know what's going on in your code, right? You kind of have to remember what's happening in your code. And so a way to kind of make that easier for yourself is to abstract away complexity so that you can choose your investment level. Maybe if I'm reading somebody else's code here, maybe I only care about how battle begins. I don't really care about, the nitty-gritty of how battle happens. I just care about how it begins. And thankfully, because of how we designed our code here, I can do that. I can choose my level of investment. I can say, okay, here's how battle happens. I don't know what happens here in take player turn, right? I'm not sure what happens in that function. I'm not sure what happens in take monster turn or in conclude battle. But I don't care what happens in those functions, right? All I care about is how battle starts. So thankfully, because of the way our code is designed, I can sort of get a feel for how battle happens without knowing the nitty-gritty of how it works. And if I want to know how it works, I can actually just scroll up, right? I can say, well, how does take player turn work? What happens on the player's turn? Well, I scroll up, right? And we find up here take player turn. So I can learn about how the player's turn happens. And again, we've abstracted complexity away, where it says here, if the player wants to attack, then run turn attack. Okay, so I know what's happening. From here I can see that the player types in an input, they type in attack, defender, item, and then based on their decision, something happens for each one of those things, right? So I know that's how the player turn works, but I don't need to know necessarily exactly how the attack works, or how the defend works, or how the items work, right? But if I wanted to find out, I could, again, scroll up and find it. Right? So that's kind of a principle in Python to consider, is to, if you have one block of code where things have gotten too complex, it can be very hard to read what's happening in that code. So you might want to kind of make things more modular. Again, hide the complexity. If there's a part that's doing one certain job, then make it do its job in a function. Don't have it make it do its job in this big block of code that's already got tons of things happening in, right? That's kind of an idea we discussed last time. Thank you for the follow, by the way, Koopa Troopa 174. Welcome to the channel. If you have any questions, let me know. So Dix shows up and says that The Adventures of Cookies and Cream is the hardest game of all time. Huh? That's the hardest game of all time. Dix's favorite game in the Souls franchise is The Adventures of Cookies and Cream. Fao says, the thing is, I played a lot of From games before the Souls series, huh? So it's kind of accustomed to the bullshit. My brother used to love the Armored Core series. And Kingsfield, huh? They made a Kuon as well, which is pretty awesome. What the hell's Kaidan type game, huh? Everyone thought the Sekiro teaser was for a Kuon sequel. What's up, Black? Welcome aboard, dude. The original teaser for Sekiro was so vague and lacking information, I'm not really that surprised. That's why I don't even bother with these fucking teasers. Maybe they'll continue the next teaser for an AC and C sequel? That'd be sick. It's about damn time. It's From's only true masterpiece. Armored Core was cool, but the combat was kind of janky. Yeah, whenever I watch my brother play it, I'd want to play it myself. It looked like really fun to make the robots and stuff. then I'd watch him fight and be like, yeah, I don't know about that. It's a horror story, but specifically with an air of an older time about it, huh? Like, kind of historical. Anyway, guys, so as you can see, we've kind of been focusing on what it means to move complexity away from your code. And we're going to move away from that now. We're going to keep that as a core principle of our design, but also consider how we can tie that to object-oriented programming. Right, so if you look at the top of our code here, we've begun, but not finished, defining classes. Our last stream kind of got cut short. So we have these old functional designs where we have a bunch of literal functions, right? But they're loose. As you can see, they're fully indented to the left, which means that they are in the basically the top level of our code. They are just floating around loosely in our code. They're not a part of anything else. They are just functions, right? What I want to do instead is I'm going to move these functions into classes where they make sense, so that we're going to have these you could consider them as objects, these things in our program that have about them properties, right? These things, like, think of a person, right? A person can they can walk, they can jump, they can talk. People are, if you think of a person as an object, like I do for women, then you can, I don't actually do that as a joke, but also you can have them do things, right? That would be their methods. But they also have a hair color and an eye color, and they've got a height and a weight, all this other stuff. Those are all properties, right? Those are all things about that person. And objects in programming are the same way. They have things about them, and they do things, right? So how can we make things such as, player's turn and the player's turn attack and the player's turn defend an item? How can we make those things part of an object? Well, it's very simple. They belong on the player object, right? And a part of being an object-oriented programmer is to make decisions about how to divide up responsibility for your program among objects. It's not as easy as it sounds, right? Like maybe turn item should be a feature of the battle, not the player, right? And making decisions about who gets what ability, who's responsible for doing what, that's kind of a job you have to manage as a programmer. An object-oriented programmer, that is. What's up, Nordis Power? Welcome back. Yeah, that would be on GitHub. Thank you for the link, Faust. On the topic of From, a Metal Wolf Chaos game was announced a while. I forgot about that. Whatever happened to that game? It was announced, yeah. I never heard anything about it after that. So basically, we have these loose functions going around right now, and our job today is to put them into objects. The benefit of that is twofold. One is that when you have your code organized into objects, it's easier to read. Right? It becomes more clear what kind of responsibilities are being handled by what thing. If I go up to the top of someone's code and I see a protagonist object, I wouldn't be surprised to see that it also does things like attack and defend and use items, right? That makes sense to me. So again, because it makes sense, it makes common sense, it makes your code easier to read. Same with these items, right? I have this spear item here, this class, and this potion item, and other items in the future. And basically, they have this use item method, both of them do. And they have a name and a gold value. That's how much they sell for, how much they buy them for. And for that reason, it's kind of easy to understand how they work, right? These spears, you can use them. When you use them, they do this, right? You have a potion, when you use it, it does this, right? It's kind of nice. So we're going to kind of be making this into an object-oriented design. And finally, guys, the final advantage of using classes, maybe the most important reason to use classes, is that it becomes easy to manufacture objects on a large scale. So, previously, when we wanted to make a new potion, it would be kind of a pain in the ass. We'd have to kind of define it from scratch every time, more or less, right? But now we have this class, which you can think of as a mold. And from this mold, potion item, we can very easily manufacture potions. We can just spit them out like nothing. We'd have 100 potions instantly in our game, right? And that's also true of things like monsters. Once we make a class for monsters, we can manufacture monsters very easily. If we want to have more than one kind of monster that have very similar stats, but maybe they have different names or sprites or abilities, we can do what's called inheritance, right? Classes can be used through inheritance to make other classes simpler. Think of it like using a mold to make another mold, right? To make another mold, to make another mold, to make another mold. Basically, you're going to find that using classes makes your code easier to read, and it saves you a lot of lines of code. It can make your code, make your game much faster to expand and get bigger and more interesting and more dynamic. All these cool things that make your game more fun. Or any program, right? We're really like game designers here, but you can use this for any kind of program you're going to write. Whether it be like a chat room or something that's designed for parsing websites or a web server, whatever. These are all sort of ideas that are central to programming, not necessarily game design. Let's see here. They realize people only care about Dark Souls, huh? Metal Wolf Cast is so sick though. It's last year's E3, but they don't seem to actually care about releasing mecha games anymore. Yeah. Well, Derasine's there to capitalize on Derasine is there to capitalize on the VR trend, right? Okay, let's get cracking here, guys. So one time, I want to stress again that this show, Intro to Python, is meant to teach Python to total beginners, but we do it over 6 episodes every season. And episode 1 is what is a program, what is a function, what is a variable, the very, very basic ideas of programming. Here in episode 6, the last episode, we're in some more intermediate to advanced concepts, which means I'm not going to spend too much time talking about what is a variable. I really want to kind of knuckle down and get these functions into some methods. So, first of all, we have a bug. I should say, it's a design bug. It's not really a bug in our program. The program will run. In fact, let's run it right now. Let's play our game, right? Run module. What's your name, son? My name is Vencabot. Do you want to fight or shop? I want to shop. Let's see, I have 0 gold. I guess I want to let's leave then. So do you want to buy or do you want to leave? I want to leave. Do you want to fight or shop? I'm going to fight then. Okay, I have no money anyway. We got a baby Goki he's approaching, right? That's our monster. He has 15 HP. I have 25 HP. Do you want to attack, defend, or use an item? I guess I'm going to attack him. Okay, so he taunted me. I did 6 damage, and he taunted me back. So there's no damage I took there. The monsters have a chance to either roll an attack turn, a defend turn, or a waste their turn, which makes life a little bit easier, right? It's kind of like a gamble what they're going to do. I did 6 damage there, so it's going to take me 2 hits to kill him. Let's see if I get lucky again. I'm going to attack him again. He's not always defending, but that's fine, because I do 6 damage raw, and if he's defending, I do half damage, right? He's covering his belly right now. I'm going to do 3 damage. He has 3 health. That's my kill. Let's finish the job here. Boom. Easy win. I got 5 gold. Now I'm carrying 5 gold. Let's go back to the shop again. Okay, so the spear costs 15 gold, and the potion costs 10. I can't afford either one. I'm going to leave. But I believe I actually have a small inventory already. I think I start the game with 1 spear and 1 potion. Let's fight. We got an actual Goki here. He's a lot tougher to beat. He has a little more health and a lot more attack power. I do 6 damage per attack. He has 20 health. If I use my spear that I have, I do double damage. So it'll still take me at least 3 turns to kill him. That's kind of a drag. The cheapest VR setup you can get right now, at least $300 or so, I think. Huh? Well, is that... If you have a PS4 already, isn't the PS4 headset only like $150? Something like that? Yeah, exactly, yeah, Faust. Not counting upgrades, yeah. Okay, so let's I guess attack him. He's defending now. Let's attack him again. I got lucky there. So now I can kill him with 1 spear. I'm going to do it to finish this fight. The spear does 12 damage. He has 11 HP. Let's use an item. I want to use my spear. Boom. Killed him. Awesome. So now I've got 15 gold. I can afford to buy another spear if I wanted to. Maybe I should. Let's go do that. Let's go to the shop. I want to buy a spear. There you go. Now I've got 0 gold left. Let's go fight again. Okay, I'm fighting a baby Goki. Let's attack him. He's defending now. Let's attack him again. Okay, he tattooed me, so I lost, how much health there? 7 health? That's pretty bad. Let's attack him one more time. Alright, let's go fighting again. Another baby Goki. I can survive quite a few more attacks, right? I can survive, I'll die in 3 hits. Let's attack him. Let's attack him. I got lucky there and attack him again. I got 10 gold. I can buy another potion now if I wanted to. I think I'm going to buy a potion to survive. If I get bad luck against a Goki, I can survive with a potion. Let's go buy a potion here. Now I'm broke. Let's fight. It's another baby Goki. Let's attack him. Okay, he taunted me. I can kill him in 1 hit with a spear, but I'd rather save my spears for the big Gokis. Let's attack him again. And attack him one more time. I got lucky there. Let's fight. It's a full-size Goki now. I want to attack him. And attack him. Oh, I'm almost dead. Let's use a potion. I'm not sure it'll save me, though. I get 10 health from a potion. That tattoo hit me hard. I had 17 health, I did 15 damage, so a potion won't even save me. But I can kill him in one hit with a spear. Let's do that. So I want to use an item. I want to use a spear. Okay, so I have 15 more gold. Let's go to the shop. And I want to buy a spear. Okay. Let's go fight. I want to drink my potion and hope for the best. We got a new Goki here. This Goki is an adult Goki. He has 15 damage per hit. The potion heals 10 HP. So I'm going to drink a potion, have 12 health. If he attacks me, I'm dead. If he doesn't, I'll survive. Go to item. I'm going to use one of my 2 potions. Oh, what happened? We had a bug there. Alright, so the potion, yeah, we have a bad, we used the wrong term here. So basically we typed in the word player into this dictionary as a key. We wanted protagonist, not player. That's on line 63, it says. Let's go find line 63. Look down here in the lower left here. You can see we have our line number. So line 63 is going to be up here somewhere. Okay, let's see. That's 58. Here it is right here. Game state protagonist inventory.remove. Right, so we talked last time about attributes, right? What tells an attribute? What tells a method? These are things that are attached to a class or an object. And in Python and other languages, the period is the equivalent of the apostrophe S in English, right? It implies ownership. So when you see things like, protagonist.inventory, that means the protagonist inventory. And it says .remove, that means use the remove method that belongs to the inventory that belongs to the player. So the remove method is a method that belongs to any list in Python. That will remove an item from a list. So we're saying here, remove the potion from the player's inventory, is what we're saying. Use the remove method of the inventory that belongs to the player and remove this thing. Yeah, Google Cardboard's like $5 though, huh? Does it actually work at all though? I knew like one person who did that in high school, and he learned better when someone checked his history during class. Watching porn on his phone in class? Oh, no, excuse me, he watched it at home, hopefully. And then in class when he checked his phone history, huh? What an amateur, says Faust. Everybody knows you use a different browser just for porn. Or incognito. I like Faust's idea more. It's more risky. Makes it more exciting. Okay, cool. So our game's working now. We have an idea how the game works, right? We can just keep on fighting and buying potions until we die. Right? There's no way to keep score yet. Hopefully by the end of today, our protagonist will level up and get stronger somehow. So let's look at a bug we have in our design. And that is that the use item method of the spear and the potion, it should not require the game state. That makes no sense. It makes more sense, in fact, to have the potion itself be aware of its game state. So to that end, it makes sense to have it be an init argument. We talked last time about init. Init is a method that all classes have. Whether or not you specify it is still there. And it defines how the class is initialized. What happens when you make a new object from this class, I should say. Right? When you instantiate is the word, right? Basically, if you use a mold, which is a class, to create an object, you are instantiating that object because you are making an instance of that class. Right? You have the class, which is the mold. You're making an instance of it, which is your object. You are instantiating that class. Let's see here. The only other browser I ever have is like Microsoft Edge. We'll use that then for porn. Yeah, I try to avoid when I can risk, Austin. I try to avoid risk when I can. I hide all my porn in a folder on my desktop titled "Click this if you want to die immediately." I'd be too scared to click it personally. I'm one of those guys that always forwards those messages you see on Facebook. If you don't forward this to 10 other people, you will die a horrible death at 3 a.m. tonight. Oh, fuck. I'm sorry, guys. I gotta do what I gotta do. Alright, guys. So basically, we want to change our init method here for our spear from only requiring nothing. Right? We talked before about how self is an argument that all methods have. The first argument of any method is always self, which is the object that has been instantiated. Right? It is the object that's been made from this class. And it's so inherent to methods that when you actually run the method, you don't actually have to use it. You don't have to specify self when you run the method. But when you define the method, you do. Yeah, share this message with 56 other people, or your mother will die at midnight. Okay, damn chill, dude. I'll do it. Don't kill my moms. Alright, give me a second. Fuck. Let's make the game state a required argument of this spear. Right? Because to use the item, you have to know the game state. That much is clear. So the game state is basically everything about the game you have to know. That's what the game state is. So we're going to specify this and we're going to save it, right? Like any function, you can use your arguments inside your function. We have two arguments, self and game state. Remember that self is the object, the spear in question that we are creating, right? So we're saying here, this every time we make a spear, we're saying it has an item name, right? Which is spear. It has a gold value, which is 15. We're also going to say here that it has a game state. I'm going to call it parent game state, right? So the spear's game state, the game state that it's a part of, is, parent game state. I'm going to actually have this change its name up here. Makes more sense to me to call this parent game state. There you go. So the game state that the spear is in is saved to the spear now itself. Now we can go down here and we can say we don't need this parent. We don't need the game state as an argument for use item anymore. We're gonna say here I want to. Oh, the spear has defined itself anyway. That seems weird. Hang on, let me see. So basically, our code before was transitional. But we were kind of transitioning between functional and object-oriented. Some of the stuff is kind of wacky, the way I did it, to make it kind of a transitional phase. For inventory item, in the inventory... Okay. Inventory dict. Oh, I see what's happening here. Right. We're making a separate... No, I don't understand what's happening here. Let's see here. So for every item in the dictionary, in the inventory, so these are all the items. Okay, we're making another dictionary. Oh, this is the classic style dictionary. So basically our inventory is a list, not a dict. The inventory is a list. That makes sense, right? So we're making a dict, so we can remove... What is the point of this dict? Where's this dict being used? Inventory dict. If spear, oh, the word spear, I gotcha. If the word spear is in inventory dict, I gotcha. So we're checking to see if they have a spear here. Why would your inventory be a dict? Why wouldn't it be a dict? Got a problem with dicks, dick sucker? Yeah, dict is short for dictionary in Python. D-I-C-T. We're talking about maps. We're talking about a dictionary is when you have a key, which is one object, mapped to another object. So you can say here, I want to supply the key and get the value out of it. So typically it's used for things like strings. Like you can say here, I want the word name to come back as David. I want the word age to come back as 31, right? It's kind of a typical use of a dictionary. You supply a name and you get back something else. Okay, so we have this, this is all really convoluted and not necessary. I gotta make this a lot more elegant here. This code right here. All we gotta do really is just find out if, yeah, we can say self. All we gotta do is say if self in the self.parent game state. Well, I'm gonna make a new alias. That's really long. If I say parent game state, protagonist dot inventory, we're gonna be using this. We're gonna be using this variable name a lot. We're gonna be using the variable name a lot here. So I'm gonna make it shorter using an alias like this. Watch. I'm gonna say here inventory. Right. Inventory equals self.parent game state protagonist inventory. Right. So now I can just say inventory and it means this whole thing. Yeah, they're unique, Kenny. Indeed, they are. So basically, the way our old code is working here, again, very sloppy and very ugly. This code right here was basically saying, if you want to use a spear, right? First, find out if they have a spear. And if they have a spear, then remove one of those spears. So it's not really saying remove this spear. So if you had more than one spear, it wouldn't really matter. Indeed, it would overwrite the value of that key spear. So you'd only have one of each item in this hypothetical inventory dict we made. But all we're saying is, remove whatever spear is there. Just if you want to use a spear, you want one of your spears. If you pass game state as an object creation, wouldn't you eventually end up with an out of sync game state? I don't think so, Dodie. I'm not sure what you mean. Under what circumstances do you think that would happen? The game state is I'm sorry, maybe the problem you don't understand is that in Python, so game state is a dictionary, right? And dictionaries are mutable objects in Python, but they're mutable. So when you pass in the game state, you're passing in a pointer, right? In C++ or Java, that'd be called a pointer. So you're not actually passing in a game state that is fixed. That game state will be updated universally by all objects because they're all pointing to the same dictionary, right? What does a game state look like? It's a dictionary where we're saving things right now. We're kind of, excuse me guys, I mentioned this earlier. We're in a transitional phase in our program right now. I was teaching functional programming before, now we're teaching object-oriented programming with the same code. I'm trying to update our code from being functional to object-oriented, and as such, our game state's kind of in a disarray. I'm going to show you guys in a second here. So I'm going to say here, I lost track what I was doing here. If self is in inventory. There we go. I'm going to fix this real quick, guys. There we go. This should be a little bit better. A little bit cleaner. We're going to say here, inventory.remove self. That's way cleaner. Our goal for today, guys, is to clean up our code, which is kind of transitional, into something that's much more object-oriented. There you go. Remove self. There you go. That's all you need to do. And we're going to say here, self.parent, game state, protagonist, moniker. Okay, that's fine. So I'll show you guys the game state now. The game state object is a dictionary. And it saves the entire state of the game, right? Everything's happening in the game. We define it way down here in our actual, this is the actual program itself that actually runs. The first thing we do is we define the protagonist key as pointing toward our protagonist object. That's the first thing we do. And then, because we're in a transitional phase right now, we do other things to mess up the game state that are not really object-oriented. Right? Next thing we do is we do a fight, right? This fight right here. When we do a fight, we make a monster object as well. We don't actually make a monster object. We make a bunch of loose monster keys inside of our game state, as of right now. Right here. Do battle says create a new monster, right? And you supply the game state as your argument. Let's go find create a new monster. That would be right here. Create new monster. So what this does here is it gives the game state a monster name key and gives it a name. Then we also get keys for the monster's HP and attack and their gold value, etc. And whether or not that monster is defending. Right? So before too long, we're going to have a monster object instead. They'll have all these as attributes, obviously. It's a text-based game, indeed it is, yes. Yeah, it's not really a really amazing game. I'm really using it as an example to teach Python. That's the idea here. It's not going to be no Final Fantasy competitor, that's for sure. What else I missed in the chat here? Yeah, that's the game state object right there. Right now, it's sort of like a dictionary that holds a bunch of loose, essentially variables. Right? There are a bunch of keys that point to values that other functions are going to need. They're essentially globals. They're kind of like globals, basically, which is you kind of want to avoid those if possible. We're going to be kind of trimming down the game state dictionary very shortly here by turning these things like the monsters and the battles into objects. Okay, so let's see here. So we've got our spear is way cleaned up now. It's much more object-oriented, which is nice for our purposes here. I mentioned in our last stream, guys, that you don't always want to go object-oriented. It has its own pitfalls associated with it compared to functional programming, but also has a lot of perks too. And today, what we're going to be focusing on is the perks, not really the downsides of it. Okay, so we have this use item code now. Okay, it seems pretty straightforward, much more than it was. Okay. All right. Sweet. I see a problem, though. Right? The problem is that it means only one protagonist can use the object. That's fine. Okay. That's fine for now. So, let's fix our potion as well the same way. So we have this kind of whack code here. where the use item method takes the game state, and then it does all this kind of whackness with it. Let's fix that right now. Let's do the same thing we did last time. We're going to add a parent game state argument to instantiation and save that to the item, so the item knows its own game state. Now it knows its own game state. That's great. We're going to make an alias for it's going to be called inventory. It's going to be self.parent game state protagonist. He's the only guy that can use items. Dot inventory. Okay. Now we're going to say here, if self in the inventory. So if this potion is in the inventory, then, oh, that's all right. Then, you know, do all this shit. I just realized something, guys. We gotta fix all this stuff up here, too. We have some typos. Right, it says here, game state. We have to change this to parent game state now. Self.parent game state. Right. Self.parent game state. Right here, self.parent game state. There we go. Okay, we got rid of our argument here. Okay. Fix all these. Excellent. Excellent. There we go. Okay, that should fix that, I believe. Let's go fix potion now. And then fix how these items are being used. Okay, so let's see here. And we have this self.parent game state. Could just use search and replace, but why? Let's be clear how it's working. Alright. And we have the self.parent game state. Okay. Awesome. Awesome. And this right here has to get fixed too. We have to remove self now. Actually, we can just say here, inventory. We have this alias we can use, right? Dot remove self. Excellent. Sweet. Self.parent game state. Protagonist, moniker. Doesn't have a potion. That's fine. Sad face. All right. So now we fixed how the items are sort of used internally. We have to fix how they're being used by the player now. Let's go down here to our turn use item function, which will soon be a method of the protagonist object. But for now, it's a function. It says you have these items. That's cool. Okay. So we have an inventory dict, right? For each item in the dictionary, do this thing. It says, what do you want to use here? Okay. So this item method equals the inventory dict player choice dot use item. And then we use that now without the game state. I don't need the game state anymore. Just use it. There you go. Sweet. Now that should work. Let's try and run it and see if it works. See if we can still use our items. What's your name, son? My name is going to be Opternary. I'm going to use his name without his consent. That's copyright infringement. Opternary. Oh, I already fucked up. Oh, right, we're defining items. We have to define game state. We define an item now. Let's go to the shop for one thing. All right, we go to our shop. We're going to be making some new items here. Where is it? Go shopping, it says, right? We have to make a spear item using our game state. We just apply the game state now for all of our instantiations for these objects. Okay. There you go. Sweet. Now let us do the same thing for when we make our character, right? We actually make some objects when we make our character. He gets a free spear and a free potion when he's created. Right here. So we need the game state here too. That's fine. Parent game state. Save this. There you go. Now he knows his own game state as well, which makes a lot of sense for our purposes. Then save this as parent game state. And then we have the parent game state. There you go. So now basically every object has to know the game state so it can do its job correctly. That seems reasonable to me. All right. Cool beanzos. That should work now, I hope. Let's find out. Okay, so I'm going to be Opternary again. Oh, still fucked up. Oh, I have to, yeah, I want to find the player now. Let's do that. Here at the very bottom code here. We're going to supply, we'll ask him for the name first. We're going to say here, protagonist name equals input. What's your name, son? Awesome. Now we're going to supply that as an argument, the first argument. The protagonist name, and then the game state itself. Sweet. Awesome. Tubular. Let's run this code. Okay, so our name is going to be Vencabot this time. Fuck Opternary. I need a space there, though. Like that. Okay. So I want to go shopping. Then I'm going to leave. So it made the spear and the potion. That worked out pretty well. Let us now go fight. We have a baby Goki approaching. Let's just try and use a spear, see if it works. I want to use my spear on him right now. Okay, it worked. Do I still have the spear? Spear's gone. I'll use my potion now. Okay. Okay, I have nothing now. Okay, what do I want to use? I can't use anything. That's fine. Okay, so that works now. Awesome. Let's go now move some of these turn type functions to being methods of the player object. Right. So right now we have this turn attack, turn defend, turn item. We have this take player turn. All these functions probably belong as being a part of the player object. So let's actually just copy this right now. The def take player turn. Copy that. And move it up here to our player object. There you go. Right here. So we're going to call this 1, 2, 3, 4. We're going to call this take turn now. Right. And we're going to use self because it's a method. That's all that it needs. So everybody knows the game state, right? The game state is saved to self. Right. So we're going to say here, you know, self is defending. Is false. At the start of each turn. Save a player choice. We have this if-elif block. It might make more sense to have this be a dictionary, actually, huh? That's fine. We'll do it with the if-elif for now. That's fine. Makes it pretty clear how it's working anyway. Okay, so I'm going to have this, we're going to say here, self.attack. Right? And self.defend is our methods now. Don't need the game state either. Okay, and we're gonna have self dot item. We'll say self dot use item, even though our other method's called use item. It's kind of confusing. I'm gonna just call this use. Right? Let's just call this use. Spear.use, right? That makes sense to me. Potion.use. Now you do not go to the turn item code and fix that down here. Turn item. Use. Now we're talking. Okay, so now we can move some other type of methods up here. Right, take turn is right there. Let's move up turn attack now. And change its name to just attack. It's a method of the protagonist class. Grab this, copy it to up here. There we go. We're gonna call this attack now. It just needs a self. It doesn't need game state anymore because the game state's saved to this object. We're gonna say here a self.moniker has slash so and so. Self.parent game state with his sword. We're gonna fix that later because we have this monster name, a key in the game state. It's not gonna be there forever. It's actually gonna be a monster key in the game state, not just a monster name. It's gonna be the monster itself who's gonna have his own name as an attribute of his class instead of just being a key in the dictionary there. Okay. There you go. you go. And there you go. Some very long lines. You guys know I like really long variable names, so some very long lines here. Maybe we'll, in the future, come back to this and shorten some of these lines by making more aliases. Okay, so let's see here. I want to indent this. Self.parent game state. Right. I can see we can shorten this right away, right? So I'm going to actually type this in for now the way it is. Minus self.parent game state. Okay. So what we're doing is we have some redundant lines. These lines, right? This line right here, and this line right here. These two are redundant. Why don't we instead just do a simple? We'll do right here. We'll say self.parent game state monster HP equals self.parent game state monster HP minus attack damage. Right, and here we can calculate the attack damage. Right? We're going to say here this attack damage equals attack damage equals the attack divided by 2. Right, it's way easier to read, way shorter. We're just calculating the damage essentially, right? There you go. Makes way more sense. Likewise, right up here, we're gonna say here attack damage equals self dot we'll just say self dot attack attack power, right? That's an attribute we have of this object, our self. Self.atk, right? So the damage is going to be self.atk, and here it's going to be atk divided by 2. There you go. Simple. Awesome. Minus attack damage. There you go. We can use minus equals, right? We learned about minus equals last time. Let's just use minus to make this even shorter. So minus equals is syntactic sugar in Python, which means that it makes things easy to read, but it is not necessary to use. It's just called syntactic sugar. It makes things a little bit nicer. And in this case, what minus equals means, it means take this value on the left and then increment it by the value on the right. I should say decrement it, make it smaller by the value on the right. So you have plus equals, which would make it larger by attack damage, or minus equals, which means make this bit lower, by attack damage. There you go. So it's going to lower it by that much. It's excellent. Awesome. Okay, so we have this attack method now. It's going to be pretty good so far. Let's print off this last message here. Self.parent game state. Okay, have its name there. It'll be so much easier when we have a monster instead of having all these random game state values. We're going to have actual monster object very shortly here. Okay, so we have this attack now. That should work fine. Let's go and get this defend. It's pretty simple. Way more simple than the attack is. It just basically flips a flag. The defending, player's defending flag. Let's go down here. And then paste this. 1, 2, 3, 4. 1, 2, 3, 4. We're going to say here, self.isDefending is now true. And then we're going to print off our name, raises his shield. So self.moniker. There you go. Easy. Now we can defend. We have to change the name of it too, from turn defend to just defend. And then we're going to supply self. Don't need the game state anymore, because that's actually saved to this object as self.parent game state. And now we can go get use item, or the turn item, I guess, right? Let's do this. Okay. Go down a couple lines, paste that, indent it. Okay. There you go. So this is going to be pretty simple too to kind of port over. we're transitioning from functional design to object-oriented design. So we have this little, we're going to call this use item now, not turn item, but use item. It's going to need to have self, not the game state. Otherwise, it works very similarly, right? That's why we're kind of porting things. It's not actually rewriting, just kind of porting stuff. So now we have self.inventory, not game state protagonist.inventory, because now we're actually inside the player object, so self refers to that player. Okay, cool beans, cool beans. Awesome. All right, sweet. Awesome. Key error. We're going to say self.moniker isn't carrying that. Should make it into one line, easy peasy. Awesome. Sweet. So that should work fine now. So now we have this take turn method, which runs these other methods if you want to take your turn. Awesome. Sweet. Got spears. Potions are working well so far. We're going to have to change this create new monster function to being a class, right? We're going to create a new monster as an object, not as this bunch of loose variables. That's fine. Here's take player turn, get rid of that. Don't need that anymore. Okay, monster turns, sweet. Okay, awesome. It's excellent. Do battle. So, why don't we, before we get too far, make this monster object. Then we'll fix how do battle works. Let's make a monster object very similar to our player object. It needs a name, HP, attack, and a gold value, huh? Fine. Be that way. Let's go up here to where we made our protagonist and make our monster. Class monster. With capital M, right, guys? Classes always start with capital M. Or capital letter. Define a new init method. All it's going to need is its arguments that it needs to become a monster, right? It's going to need to have some amount of HP. Right? Let's give it... what's the order we define these in usually? We define them in the order of... we'll do attack, then HP, then is defending, right? That's really all there is to a monster in our very simple RPG here. We're going to give it an attack value, HP value, and that's really all it needs. So we're going to say here self.attack equals attack, self.hp equals HP. There you go. Easy peasy. Thanks for the sub, Locust. Holy shit, man. 4 months. He says, dang, 4 months already? You're the man. Vencabot. Watching and playing 3S with you have helped keep my spirits up during tough times. Dude, I'm glad that it's worth something to you, man. It's a pleasure having you. You're always a pleasure to have in the chat and to have some good games with. How you doing, man? Some tough times? You know, my life got to be that way, dude. I know you're struggling with health problems and stuff right now. Which is, it's being an understatement to say it's not very fun, right? Let's see here. I'm very grateful every day that I have my health. Sometimes, it's easy to get down in the dumps about this, that, or the other thing, right? But it's also important to look at things that you have and be grateful for it. That's what I found over the last few years, anyway. All right, so we have the attack. They have the gold value as well, right? They have a gold value, these monsters. The player don't. The player doesn't actually yield any gold when he dies. But the monsters do yield gold when they die. There you go. They also have a name. A monster name. Call this, monster type. Equals, monster type. Oops. I keep thinking I'm using Vim. Loka says, it's just my health that's but. Living situations are fine, but I'm grateful for that. Yeah, not everybody has that convenience, right? As long as I've got a bed here and some food in my stomach, I'm really, really grateful. And like you said, man, having health problems is just the worst. Like, it's one of the worst things. But hopefully you find whether or not you actually, whether or not you ever actually, recover to a point where you're feeling secure about your health. At least hopefully you'll come through some times where it's not as much of a worry for you, for one reason or another. I hope so. Alright, so let's continue defining this monster class. So Locust, I noticed the last time we played, you played a little bit of Necro. Have you been working on him more a little bit? I really found over time that you've become much scarier as you focused on Ken. But I think you've been focusing on Ken so much lately, it kind of be fun to branch out as well, right? Let's see, we have his monster class here. He needs to have his turn, the monster turn, right? I think it's called take monster turn right now. There it is right there. Let's port this over. Right now it's a function. Let's port it to be a method of the monster class. We're going to paste it up here and then very slightly tweak it to make it more of a method than a traditional function. There we go. Thank you, F. It's right here, right? Self.gold value equals gold value missing. Oh, thank you. I'm sorry. Thank you, Effer. This guy's got my back, dude. I had a typo there. This man's got my back. Welcome aboard, man. Thank you for your help. What's the difference between a class and a module in Python? A class and a module. They're very, very similar ideas, KJ. In fact, the biggest difference is how they're used conceptually, right? Both a module and a class have attributes, and they've got a method, essentially, right? But you don't instantiate a module. Modules are really only there as a way to organize variables, aka attributes, and functions or methods into a big package, right? Whereas one purpose that classes have is to do that same thing, but the real most common use of a class is to instantiate an object or to manufacture an object. A class is a mold, right? It's a mold that you can use to mass produce objects, and that's not the way modules are used. But in the way that they look, with having attributes and methods, and the way they're kind of constructed, they are very similar. You're right. But yeah, a module really is just an organizational. It's an organizational structure, and a class is a tool for manufacturing objects. That's the main difference. It's tough with me, says Locust. I just kind of go with the hot hand. Sometimes I can feel like I can win with Necro. Sometimes with Ken. But as far as I'm concerned, Ken is my main and will continue to be. I think that I don't know what it is, man. I just don't know what it is. It seems like when you play Ken, you're a whole different player. It's like you really have a very strong sense of how to use his tools. We're talking about Street Fighter 3 Third Strike, guys. Me and Locust are players of Street Fighter. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And 1, 2, 3, 4. Indent that shit. We're going to change the name here to Take Turn, not Take Monster Turn. And it's going to require... Oh, it needs a game state, right? It needs a game state. We're going to give it a parent game state here. All right, let's do a hang indent. 1, 2, 3, 4. And save that too. There you go. Okay, so now we have this parent game that we're saving. Now we can say here, make us take self. We're going to say here, self.isDefending. Oh, it has an isDefending values too, right? We're going to say here, self.isDefending is false by default. And the start of a return, it stops defending, right? Just like in most JRPGs, when your turn starts, you stop defending. So self.isDefending becomes false. We're going to say here, turn options. It's going to be self.attack. Self.defend. And self-taunt. Right? So we're changing up the names of our functions here because they become methods very soon. Right? We're kind of referring to these methods we haven't actually made yet. We're going to say here that, monster action is going to be a random choice from our turn options. We're going to call this a monster action. That's all it needs, right? It doesn't need to actually have a game state anymore. It's being saved as self.gamestate. That's fine. Sweet. So we ported over that function now. You also enjoy playing Necro, but I also don't enjoy losing. Yeah, well, it's tough, man. Necro's a hard character to play with, right? He's super cool. Necro is so cool in Street Fighter 3, guys. If you guys don't play Street Fighter 3, you guys have no idea how cool Necro is. But he's kind of hard to play with. So he's going to be hard to win with for sure. But I definitely can see why you want to learn to play him and learn to play him better over time. That's the struggle, though, right? The struggle is how do you get better at playing a character if you're scared to play them because you don't want to lose. Right? You have to be able to lose to learn. It's really frustrating. Makoto is a really cool design, Professor Q. But if I were given, a gun with 2 bullets, and I had Hitler and Makoto and, my ex-girlfriend in the same room, I would shoot Makoto twice. She's one of the scariest for sure. Like, her and Oro are just so crazy. The key is to realize you're a loser the moment you start playing 3S, so it doesn't really matter, huh? You're right. I didn't even think about that, Dix. Alright, so we have a turn for taunt, defend, and attack, right? So we'll make these into methods. Port them over. It's kind of our job today here, is to kind of port over this old code. Let's go up here to our monster class and give it a new method for attacking people. That's what monsters do, right? They attack people. Indent that shit. If I run the game as is, it'll probably just crash. Want to try? Because right now it's kind of in a very messy state. It's going to crash a million different ways. Let's do it. Let's do it! Let's crash it. What's your name? I'm going to be Vencabot. I'm going to fight. Here's what's crashing going to happen. Boom. Right, so basically we have a lot of code right now that's kind of in a transitional phase. Like I've been saying that all night, right? We're kind of changing things over from being the old code to the new code. So it's trying to find this function from the old code that does not exist anymore. It says, wow, your game sucks. Yeah, it does. It doesn't even work. You made an MMO before. Yes, I have, Professor Q. Indeed, I have. Not a very good one. And that's my passion. My passion is two things for programming, right? I like making RPGs, and I like doing networking. So as you might imagine, one of my most frequent projects is making like an online RPG. I do it all the time in various phases of success, right? They oftentimes are playable, but not that interesting. I usually get so far as like having you be able to walk around and hit stuff, but then I kind of lose interest. All right. So let's fix this attack turn, right? We're going to call this monster.attack now. It's going to be an attack method, not an attack function. It's going to require self, because it's a method. That's what methods do. It has a self.monster type now, not a monster name, but self.monster type. Right? Tatsumaki, self.parent game state, the protagonist. Right? He has a moniker. That's fine. If self.parent game state.protagonist is defending, well, then he's going to have to lower his HP. We're going to give this a calculation for damage, right? We're going to call this, we'll say down here, self.parent game state, protagonist dot HP minus equals attack damage, right? That's what we did last time. We're going to call this attack damage equals self.attack divided by 2. Way shorter now. We're going to say here, otherwise, attack damage equals self.attack. Very, very simple. One of the many benefits of making our stuff into objects. Is there a tutorial for MMO on YouTube or anything like that? Not really, Professor Q. I've considered doing networking code in the future here, but a problem I have, Professor Q, is that in terms of viewership, I find that as our projects get more advanced, like today, for instance, we get a big drop-off in viewership. It seems like people really want to watch the beginner-type stuff, like the day one, what is a function kind of stuff. Right? As we kind of move forward into more advanced topics, we get a lot of drop-off in viewership. I would love to make an MMO on stream with you guys. That would be really sick. In fact, very soon, me and Carrick Jr. and some of our friends are going to be making our RPG that we're developing go online. It's not going to really be an MMO per se, but it'll have some online elements. I would love to make an MMO with you guys, but it's not really the kind of thing we can do in one stream. It'll take many, many streams, and then even then, it'd be kind of advanced, so I think people wouldn't be that interested. That's my feeling. But definitely we can talk about it, though. We can talk about that. I'd love to do that. That's one of my things, is making online games. I love doing that. But again, we used to make a online Battleship clone here. We were making like a Battleship game online for a while, and the viewership was just abysmal. People didn't really care about all this advanced type stuff. They wanted to learn more about the basics. I can understand how guys get lost. I think for the follow, Foznificent. That's an awesome handle. Yeah, people tend to lose interest as we get more advanced, I find. It's kind of hard to keep track of. I totally understand that, right? You kind of join in for a stream. I'm halfway through a really complex program. You're looking at all this code. Like, what the fuck does this mean? Right? What does this do? It's not as interesting for people. Anyway, so let's we have the attack damage happening there. We have this self.parent game state, protagonist moniker. Okay. Right, print off, his HP. That's fine. Awesome. Awesome. We can save a lot of code by just making an alias here. Protagonist equals self.parent game state protagonist. Right, now we can change all these from being a million lines to just being one line. Or just from being like a million characters to being a small handful of characters, right? Let's just do that real quick. Just saving one variable under a new name here. That's what we're doing there. Right, because there are a lot less advanced programmers, huh? There are a lot less advanced... Oh, yeah, exactly, Echo Tree. Yeah, exactly. I look at this stream here as a way to teach beginners how to program, and to me, that's really important. I really am very proud of that. I'm very proud to have been of any use to anybody here. But when we're doing more advanced stuff, I think that, like I said, there's not that many people interested in learning that on Twitch, which is totally understandable. It's just kind of a drag. Like, for instance, I would love to continue this game, right? Today is our episode 6 of this series. And Intro to Python is a series that goes into 6-episode seasons, right? Every 7th episode is the start of a new project for us, where I go back and talk about, what is a function, what is a variable, etc., etc. This is our last episode with this project. This is as advanced as it's going to get, which is still very simple, right? It's as advanced as it's going to get, but it's still very simple. And our next project's going to be, I don't know what yet. Haven't decided what our next one's going to be. I've tossed around the idea of doing something online, like a chat room, simple IM client, like instant messenger. So basically, we've been really fixated on games. We always make games here. We've made a Pokemon RPG already on Intro to Python. We made a text-based adventure game, like a kind of a puzzle game, kind of like Zork. And now we're making a more traditional Dragon Warrior style RPG. Right, we always do games here. But what if we did something, network-oriented, like an instant messenger or a chat room, something like that. But again, that requires knowing how to use libraries and classes right off the bat, which is really more advanced than most of these projects will ever get. So I don't really know. Might just be another game we can make. Maybe another RPG. Who knows? I'll think about it. Maybe like a dating sim. Yo, that'd be sick. Yo, guys, next week, dating sim. Start that off. Oh, my God. Oh, my God. I'm sorry, guys. I'm getting excited now. Anyway, so we have this attack method now. We ported it over. It's a little bit cleaner. Let's go do the defend one. Exactly, Ken. A dating sim? What about a basic 2D graphics game with basic networking and chat? Exactly, Ecto. That's one of those things where I'd love to make that, but if I were to do a project like that, that would mean that day one would need to be classes. Exactly. Skip the very basic, right? Exactly. Skip the basics and go right into classes and libraries. We could do that, but again, those are our best viewership we get is on those first couple days, where it's really, again, what is a function, etc. So it'd be kind of a risk to skip that and go right into something else. But maybe, because basically at this point, we've done 3 seasons of this show, right? If you want to learn the very basics, go to YouTube. It's all there. It's already on YouTube. We've got, again, 3 seasons already. Maybe it's time for us to start off with a more advanced topic. I haven't really decided, though. We'll see. That would make sense to me, right? But again, it's kind of tough. As a streamer, it's kind of tough. Let's do the taunt now. Very simple little function here. It'll be a very simple method now. Yes, with 3, full seasons on YouTube now, maybe it would make sense to say, hey, if you need to learn about what is a function, go check YouTube. We have 3 episodes that talks about that, right? 3 different seasons talk about that. Maybe now we can start off and do something a bit more involved. And as a result, more impressive, right? More impressive. Well, you've been here long enough, Professor Q, to know that for us, views is not really everything. Views ain't everything, but it is still significant, right? It's still significant. It's still something you gotta consider, one way or another. I'm proud that for us here, it's not everything. At the same time, you have to consider it. You can't just disregard it. Okay. Taunt's ported over. No, come on, Dix. Views aren't everything, man. Come on. Don't give me that. What's the reason for your choice of IDE? The reason is that it's what beginners have, KJot. Here on Intro to Python, the first 1 or 2 episodes is always in Notepad. Because our goal here is to show guys that have never programmed before a day in their lives that they can program. Right? I think a lot of novices who have never programmed before think that you have to have like a supercomputer and all kinds of crazy tools. All you need is really Notepad to work, right? After the first couple of episodes, we tend to go to idle. And idle comes with Python. That's why we're going to be using it here. Because again, if you're using Python, you already have idle, so there's that. My personal choice when I'm off stream is Vim. I like Vim as my development environment, but here we're going to be using idle because that's what people have if they're novices. Okay, so we've got taunt there, ported over. Let's go do the defend. We're all just numbers, says Dix. We're all just bricks in the Vencabot wall. Paying his bills all the ad revenue that he's not getting. Okay, so let's go up here to the monster, give him this defend method. And we'll be in Wizness. If you guys didn't know this already, Python comes with an IDE called idle. It's pretty good. It's not perfect, but it's serviceable. Okay, I'm going to say here, print off the, this monster, self.monster type, is covering its belly. That's a defend, message. I'm going to say here, self.isDefending, it becomes true. Okay, so now we have our monster object, right? It's got some good methods, it's got some good attributes. It's pretty much fully functional. Probably a few typos in there somewhere. There's always a problem, guys, as a programmer. If you change a lot of code at once, yeah, you're going to probably run into problems for a minute afterward fixing all the typos. It makes more sense to do a small change, then test. Do a small change, then test. If you do a lot of changes, then test, you're going to probably fix a lot of typos. That's fine, though. I don't fucking care. See if I care. Typo right there. Okay. Excuse me. Yay! Awesome. Awesome. So, we have some problems now. One problem we have right away is that the player's attack type stuff, where he's reducing the monster's health, still uses the old game state keys to change these monster values, and not the monster object. In fact, we gotta change the way the monster is made. Let's go down here and do that. So here we have the game state, and we make a player inside that game state, right? We also gotta make a monster now. Let's go up here to where we do battle. The do battle function. Right here. It makes a new monster, right? Create monster from the game state. But we're going to change the way that works. We're going to instead make a monster object. We're going to say here, game state monster equals a new monster. And it needs what? It needs a monster type. We're going to call this, a baby Goki for now. It needs some amount of attack. Baby Goki has how much attack? He's got... what's his stats here? He has 8 attack and 15 health. Okay. Let's go fix that. So he has 8 attack, he has 15 health, and he has some kind of gold value, right? 5 gold value. Then it needs the game state. I think that's how that works, right? The type, the attack, HP, gold, game state. That's right here. Name, attack, HP, gold, game state. Okay, cool. What is the self that you use so often? Just a bit late, I think. Yeah, so self is the first argument of any method in Python. Right? If you look at these methods here. So basically, we talked before about how in Python or any other programming language, functions take arguments. Let's go here and review how that kind of looks, right? You define a function, and then you feed it some data, right? Like do battle here, right? Do battle, you're going to feed it this game state object, right? When you give a function an argument like that, it can then use that argument in its functional code. So down here we can use the game state, as you can see, right? We're actually referencing that game state. But unless we're using globals, which you don't want to use, don't even think about globals. But typically, a function can only use data that is fed into it through the game state. Excuse me, through the argument field. Right? We have arguments right here. So now it has access to this game state. Right? Awesome. We can use that game state in the function. Awesome. So self is a default argument of a method. A method is a function that belongs to a class or an object. Right, so we'll go up here to our classes. All of these indented methods here, these functions, are methods. So their first argument is always going to be self at all times. Right? This one only has one argument, and it is self. And then self is the actual object that you have made from this class. So here we're saying, use this class potion item to manufacture a potion. Self refers to the potion that you made. Right? Exactly, Kenny. Yeah, if you're a beginner, you don't know what instantiation means. It means that the class is a mold, and that mold will make an object, and self refers to that object that you made. So we're saying here, when you initialize a potion, then give that potion the parent game state. Give that potion the item name. Give that potion the gold value. And then every method of that potion actually takes itself as an argument, which means that it has access to itself. Right? So we're saying here, where's a good example of that, right? So we had defined this gold value, right? If we go down here to our shop, our shopping code right here, we can print off that gold value right here, right? So every item has a gold value, every potion has a gold value, because when we used that mold to create that potion, it stamped it with itself's, its own gold value, right? So self refers to the object that you are making with this class. Look at it that way. And every method of that class or that object has access to all of the attributes of itself, because it's always an argument, right? So every method always can use its own attributes, of that actual object, which is very convenient. That's really a big part of what makes object-oriented programming so strong, so powerful, is that, the object itself has things about it. It has these attributes, right? Like self.hp, all these attributes it has. And then you have access to these attributes in any of its methods. You can mess with them, you can change them, you can read them, and that makes your methods a lot simpler. Like right here, for instance, right? On take turn for the player, the player gets his turn, we can reset the player's is defending value, right? So our player can lower his shield at the start of every turn, because whenever we take a turn, we always know who we are, right? We know who's taking that turn. It's self, right? That's kind of the idea. Okay, so where are we at? We got monsters. We got we're gonna change how monsters are made, right? Let's go change how the monsters are made and do battle. Do battle. I'm gonna save this create monster function, even though we're not gonna use it anymore. We don't need taunt or defend though. Those are methods now. We have do battle. Okay, cool beans. So we're making a monster here, Baby Goki. That's great. We don't need this anymore. Let's create new monster. All right, so we have this monster now. Now we're gonna say here, instead of saying print game state monster name, we have no more monster name in this game state. Instead, we have a monster, and that points to a monster object, and that monster object has a monster type. Right? So he has an attribute called monster type. We're gonna print off again. He has no monster name. He has we have a game state monster, and it has a monster type. He doesn't have monster HP, right? It's not in our game state anymore. It's not a key in our dictionary. Instead, we have a dictionary. We have a key that's monster, and that monster inside the dictionary has an HP attribute, right? So it's not, monster HP as a key anymore for the dictionary. It's monster that points to a monster object. That monster object has a attribute called HP. So again, period is a possession in Python, right? In English, we use apostrophe S. That means ownership. The monster is HP. But in Python and most programming languages, a period implies ownership. So there you go. Monster is HP. Monster.hp. Right? Sweet. Okay, once again, right down here, right? We have no more monster HP key in that dictionary. We have a monster key, and that monster has an HP attribute. Okay. We don't have a take player turn. We have a protagonist.take turn, right? We have a game state protagonist. He has a take turn method now. that requires no argument. Now, what do you mean it requires no argument, right? Don't methods require self, don't they? Let's go review, right? So we have this protagonist. He has a take turn method. There's no argument there, right? Let's go look at the actual method itself. Okay, well, I'm confused, right? There's an argument defined right there. It says self. We require self, right? So how come I can call it with no argument? That's because self is implied. So when you have a method, its first argument is always self. And so when you call that method, you don't need to specify self, right? Believe it or not. It's the only case I know of outside of optional arguments where you don't need to specify the argument. So right down here, if I go to our do battle code, right, we have this take turn, right? We don't need to type in, we don't have to type in like, self or, game state protagonist, right? When you call a method, self, the first argument is taken from whatever's before the period, right? That's your self. So when you call a method, this gets put into the first argument slot automatically. So we can just call it like this. It's totally empty. Thank you for the follow, Fear Warden. We do Python programming tutorials here every Friday. We're a variety stream, guys. Don't get too discouraged if you see me playing some Street Fighter or some Smash Brothers or some Minecraft or some Hitman. We do a variety of content here. On Fridays, it's always Intro to Python from around 6 to around 9 p.m. Eastern Time. Right now, it is 8:47. We're going to run for a little bit longer here. We kind of got started kind of late today. Probably run for another hour or so. Fixing our game up. This is episode 6, guys. Intro to Python is a 6-episode series that runs on a seasonal basis. So after every 6 episodes, we start a new season. So next week's going to be episode 1 of a new season. Maybe do a dating sim. How about that? This is our most advanced episode. Episode 6 is where things get kind of advanced, because we're kind of start off very beginner focused and then kind of end up kind of advanced. So if you're kind of getting left behind, I apologize. Go check out YouTube, guys, at youtube.com/Vencabot archive. Or just search on there for Vencabot. You find me that way too. We have all of our episodes on there. Seasons 1 and 2 are there fully. And season 3, this season, is almost done on YouTube as well. I update GitHub every single day, yeah. Every time we do a stream. Yeah. That's at github.com/Vencabot/intro_to_Python. You can go read this code over there if you want. Okay, I'm sorry, guys. So, yeah, but not during the stream, though. Only after the streams to get actually updated. Okay, so let's see here. We have this, print off a new line. Okay, we have this game state monster HP. That's not a thing. We just have this monster now. And he has an HP attribute. There you go. We don't have a take monster turn function anymore. It's not a function. It's a method now. We're going to say here, game state monster take turn. There you go. Awesome. Okay, we conclude battle. All right, the player's got HP. That makes sense. He has a moniker. Good. He has a purse. Awesome. This is all object-oriented. But here we have some of our old code, right? The monster gold value. It's not a key anymore. Right? It's not a key. We have to actually have this monster key now, which points toward a monster object. And it has itself a gold value. There you go. Can you try doing a weekly poll? Maybe have a set beginner day and a set intermediate days, and then a poll. It's a good idea, Ecto tree, excuse me. But the problem with that is that we're really more of a stream focused on gameplay. We do a lot of gameplay here. To me, programming is something I've started doing kind of recently on Twitch. Previously, our viewership for gameplay would have rioted. Right? They want to see Street Fighter, they want to see some Dark Souls, they don't want to watch programming. But I kind of, over time, found that I can do programming here once or twice a week on the channel and kind of get away with it. But yeah, I can't really be doing like an ongoing programming segment here. It's not really a fit for our channel. Yo, what the fuck, Austin? The Grubhub guys drove off with your order? I'll port your code example to Rust, I can. Yeah, if you want, Nordist, by all means, if it pleases you. Whatever makes your dick hard, homie. A guy actually stole your Taco Bell, huh? And marked it as delivered. Oh my god. Yo, you reported him, right? That's insane. You didn't pay twice, did you? You probably must have paid twice, right? That's crazy. That is crazy. Gotcha. What's up, Philip? Call it 8675309. I like how you use the letter O. 309. Good stuff, Austin. That's hilarious. Okay, so we have this monster gold value here as well. Let's fix that to being the monster object's gold value. Right. Sweet. Here we have this monster name. Going to turn that to being monster object's monster type. There you go. You should, Austin. Write a song about it, dude. Got my money back and free Taco Bell. Nice. Not too shabby. All right, so conclude battle kind of works now. Let's go through our rest of our code, make sure that our code is updated for our new object-oriented design. What else are we missing here? Protagonist moniker, that's fine. Okay, gold values, that's all good. Purse, that's fine. All right. Excellent, it's all good. And maybe it works now. I doubt it. Let's go to our items, right? The items actually lower, like the spear. Right here, see? Lowers the monster's HP. That's not going to work anymore. Right? We have to actually have the monster, the spear, lower the monster's... Well, look, we have a lot of long lines here, right? See this monster HP, protagonist name over and over again. Let's actually fix this by mixing some aliases. Let's just say here that protagonist equals self.parent game state. Protagonist, make that a lot shorter. And monster equals self.parent game state monster. There we go. So some aliases, making this a little bit shorter. I'm going to say here, you know, monster dot HP equals monster dot HP minus protagonist dot attack times 2. Way shorter. Way shorter. Print off protagonist moniker. Right. Hurl the badass spear at. The monster's monster type. Right. Way simpler. There you go. We're going to say here, replace this long-ass variable name with monster.monster type. We're going to convert its HP. Monster.HP. There you go. Might even fit on one line now, huh? There you go. Awesome. Sweet. Let's go to the Wawa. I wish, dude. I'm getting kind of hungry. Let's see here. Auto-tune fart? What are you guys talking about? I feel like there's a story here that I'm missing out on. I was like, oh, Kenny. Kenny needs to sit down at a piano keyboard and see if I can figure out what I want the next chord to be in the song I posted a little bit ago. On Discord? Sick. I'll check that out in a minute. Alright, so that was a little bit easier. We have this protagonist moniker down here we can fix. Make it a bit shorter. There you go. Maybe even make it onto one line now. That'd be nice. Oh, shmane. It's not really one line worthy yet. Let's just put this on its own line then. Poop. There you go. Also, there's a thing called F strings, guys. We could use F strings, but I don't want to teach that to these beginners yet. It's really powerful, though. Maybe you can create a dunder string to show a representation of monster or protagonist. Maybe you can create a dunder string to show a representation of monster or protagonist. Not sure what you're recommending, Nordist. In what circumstance? Oh, I see what you mean. I see what you mean. That actually makes sense, doesn't it? Yeah. So we're not redefining it every single time. I could, but let's not. I think it's more overt for beginners this way. Think of the follow Kevin. That would save us. We could do that right here. We could actually do it like, I think what Nord's recommending is like this, like self.monster, right, equals, self.parent game state monster. Well, no, that wouldn't really work actually, because it actually wouldn't work in this case. because this will actually save this monster at spear creation, right? And that monster's going to change eventually, so that wouldn't really work. But yeah, I see what you're coming from, though. I see what you're coming from. All right, so that's cool. We made that a little bit neater looking here, the spear. I think potion should be fine. It never refers to the monster ever. Right? We could probably save a whole bunch of text by just saving this protagonist as an alias. Self.parent game state. Protagonist. Right, let's do like that. If self in protagonist.inventory, then protagonist HP gets updated. That's fine. Excellent. In fact, let's just use a plus equals here, since I actually taught you guys that for a change. Some seasons we actually never touch plus equals, but we have this season, so let's just use it. There you go. A little bit neater. No third strike tonight, Philip. I'm afraid not. We don't ever run 3S on Fridays. There's gonna be some Hitman very soon. Hitman Blood Money, and then some Minecraft. Yeah, but no third strike. Protagonist.moniker. Yo, moniker's like one of the nerdiest words of all time. I always try to avoid using the word name as a variable in Python, because name is a protected word in many languages. I'm not sure if it is in Python, but it's kind of a good habit to avoid using the word name. So I use moniker. You can use nickname or other things like that. Or like protag name, like protagonist.protag name. But I don't like to use the word name as a variable name. Anyway, so it's protagonist here. He's a moniker. Okay. There you go. Awesome. Okay. Put it in one line now. Protagonist.inventory.remove self. Okay. Is it okay to write several classes in one .py file, or is it just to make it easier? JDan, you can write as many classes as you want in one .py file, for sure. As many as you want, no problem. The only reason to break it up would be if, into more than one file, would be if you get a very, very long file at some point, and you decide that you want to make it easier for you to read. It can make sense then to break up your .py file into multiple modules. That way they're kind of, more organized that way. But if you have like some small classes, or you have a pretty easy to understand module, then just leave it as it is. You don't got to break it up. Name var could also work. I don't like to use the word name, if I can help it. Okay, so we fixed all that nonsense. Let's go up here. Get rid of this inventory line. I just realized I don't need that anymore. We can say protagonist.inventory. Okay. There you go. Sweet. So our code is much cleaner now. It's more object-oriented. It's still not completely updated yet, though. We have a few more things to do before we can actually get this code fully object-oriented. But it's already way, way nicer than it was when we started. Way nicer. Okay, so we have this do battle function. We have this conclude battle function. Let's go shopping. That's all of our remaining functions. Nice. So let's run our game and see if it works at all. Monster type, monster HP, monster type take turn. Okay, let's see if it works. There's probably a whole bunch of typos. I'm gonna run this code in like an hour. Let's see what happens here. I guess I'm going to be K. Reich Jr. this time. I want to fight. Okay, we already have parent game state. Monster has no attribute parent game state. What? It's supposed to. Right. Oh, wow, I fucked it up again. Yo, how did I do that twice in one day? It's so weird. It's going to be parent game state. Earlier, our friend Elf, whatever his name was, helped us with that problem. That's funny. Okay, let's run this code again. Is it possible to code a GF? I'm so lonely. I'm thinking, Gator, tell me how you feel about this. I'm thinking next week for Intro Python Season 4, Episode 1, we're going to start programming a dating sim. How do you feel about that? Dating sim for our next project here in Intro Python? Who would join me in that? Who would want to program that with me? That'd be crazy, right? Program GFs or BFs. Let's see here. What's your name, son? I want to be named Vencabot this time. Because he glitched it out last time. Let's fight. Okay, we got Baby Goki. That's cool. From Thich. Import waifu. Alright, so let's see. I want to use an item, I guess. And spear. That worked. Item. I have a potion left. Let's use that too. Also worked. Let's defend. And defend again. And defend again. Okay, so I took fractional damage that time. That worked. Let's attack. Okay, so he has a monster name somewhere still. We don't want that monster name value. Where is that at? Let's see here. Do battle. Take turn. Attack. Line to 35, huh? It's pretty high up there. Here to attack somewhere, right? Aha! Yeah, we have this old code here for the monster. Right? We don't have these keys anymore. Basically, I'm going to make a new value here called monster. Monster equals self.parent game state monster. There you go. We're going to say here slash monster.monster type. There you go. As a Tengu man would say. Alright, we're going to say here monster.isDefending. Right, not this key anymore. This is old-fashioned code. Alright, we don't have a monster HP value anymore. We have a monster.HP value. Okay. We don't have a monster name anymore. We have a monster.monster type. And we have a monster.HP here. Awesome. Sweet. There we go. That's much better. Alright, so that's looking pretty nice, pretty sexy, pretty slim. Right, making the code more slim. It's a big advantage of using objects. Okay, looking pretty nice here. What else am I missing? Anything? We have this monster. He can attack. That's fine. Minus equals. Good. Good. Protagonist type stuff. Awesome. Spear. Sweet. I'm going to use a minus equals right here. Get a little bit slimmer. Sexy. Sleek. Lean. Lithe. What else we got here? Potions. We're going to use plus equals. We already did right there, actually. Okay, cool. Awesome. Sweet. Looks all good now. Make the sim the chick from Total Recall, huh? Total Recall. I'm not sure I know what chick you're talking about. Athletic. Alright, let's run this. Run the module. Okay, what's your name, son? We're going to be Carrot Jr. again. I trust him this time. I want to fight. Okay, I want to use an item. I want to use my spear. Okay, I want to use an item again. I want to use my potion. Okay, I got some health back. I'm going to attack him and kill him now. I got some gold. Nice. I want to go fight again. Okay. New Baby Goki's at 15 health. Let's attack again. Attack again. Did fractional damage. Attack again. He tattooed me. Attack him again. Okay, cool. So it seems like everything's working now. Awesome. But, you know what we can do now? We'll have to do two things. We should actually, before we make more monster types, let's actually fix our battle. Our battle is still very much functional. It has this conclude battle and this do battle. I think I want to make a new battle object, right? The battle object will contain... no, is that necessary? I don't know. So basically, when you're an object-oriented programmer, you have to decide sometimes, is it really worthwhile to make an idea you have into an object? Or does it make more sense for it to be a function? And here's the factors to consider. If I make a new object, will it have interesting methods? Let's say, will it have interesting attributes, right? What are the attributes of this new object I'm making? What kind of data does it have? And second of all, what interesting methods will it have that make use of those attributes? If you have interesting attributes for your object, and then methods that use those attributes, you have a good candidate for an object. But this battle here, what do we really know about this battle? It's going to have like, it could have like a take turn method that alternates between the monster's turn and the player's turn. That could be, you know, simple to understand. That'd be cool. Every battle could have its own monster, right? Instead of having the monster be loose in the game state, the battle could have the monster, right? That's one less thing to worry about in the game state, kind of. In fact, we might be able to get rid of the game state altogether if we gave the player an ongoing battle attribute, right? If we had a battle object, then the player could own that battle, right? We could have like, you know, this player has an ongoing battle. That's like an attribute it has, right? That could be a good way to get rid of this game state we've been kicking around for a long ass time. What about a DOT, damage over time effect? What's up, TF Dagger? So maybe Dagger's here from a previous stream. So basically, 3 times a week, Dagger, we do like a game design stream where we talk about game design and we try to make our own RPG that way. This is Intro to Python. This is more like a show where we teach Python to beginners. Right? It's not really the same project. We have 2 different RPGs going on at the same time, believe it or not. We have this example RPG here, and then an RPG we're making for our channel. But for DOT, damage over time, if you want, we can do that. Why not, right, Dagger? Let's make a new item. Let's make a new item like a poison dart. If that makes Dagger happy. Look at poison dagger because we have a friend named Dagger, right? Let's do it. So let's go up here to our potion item. Let's just make a new item right below it. It says gangster. Nothing more gangster than a poison dart, right? Let's go. We'll call it a poison dagger. We'll call this dagger. We'll call this poisoned dagger item. Right. Copy this in netcode. We haven't actually touched on inheritance yet. We might not be able to get. Might not even have time for inheritance today. Let's just copy this code for now. Right. Paste it. We're gonna have this, you know, item name poisoned dagger. Here you go. Gold value. It should cost kind of a lot, right? It'll cost the same as a spear. Yeah, it's fine. 15 gold for now. We're gonna have its use function, right? We're gonna use this thing. Okay. We're gonna say here, you know, protagonist. We're gonna have a monster here too. Monster equals self.parent game state. The monster, just to make it shorter. Let's call it monster for now. And if we have a dagger in the inventory of the player, we're gonna say here, you're gonna use it, right? We're gonna say print protagonist dot moniker, that's his name, chucks a poison dagger at, you know, plus monster dot monster type plus exclamation mark. There we go. Okay, we could use F strings. We haven't learned that yet though, how to use F strings here on the stream, that is. But know that it's godlike. F strings are God. There we go. Now we're talking Dagger, right? Got this dagger getting chucked around. We're gonna say here, you know, print. The dagger finds its mark. Right. They're gonna say monster dot is poisoned equals true. All right. Easy. Easy code. Then remove the dagger. The dagger's been consumed now, right? There you go. Sweet. We use up a dagger. Let's go up to our monster now, right? This monster object right here, let's give it a new value. Self.isPoisoned equals false. So by default, the monster is not poisoned, right? But whenever it takes a turn here, right? At every turn it takes, we say, if you were defending, stop defending, right? And then choose a random option from your turn options. You can either attack, defend, or taunt. That's the monster's turn, right? However, now we can say self dot, you know, we say if self dot is poisoned, then you know, print self dot monster type plus you know, rubs some sweat off its brow, right? Print self.monster type plus is damaged by the poison. Right? That's how you know it's poison, right? It's like a sweaty brow. We're gonna say here self.hp minus equals 3, right? Very little damage, but it's something, right? It's something. Okay, so took some damage from poison there. Now that should work. Very simple to add poison to our game, right? Kind of cool. Let's go give our guy a poison dagger and put it in the shop too. So again, one of the advantages of object-oriented programming is it's very easy to improve your game. It's very, very trivial. If we'd done this on day one, guys, it would have been like a billion lines of code to do that. But because of how we designed our program now, it becomes very easy to add these kind of features. Let's go to our shop, right? Give him a dagger. Very simple. Poison dagger. Poisoned dagger item. Give it the game state. There you go. Now it's for sale. Very easy. And then let's go to our where our character's created, right? Here on character creation. He gets a free spear and a potion. Let's give him a dagger too. Let's give him a poisoned dagger item. Parent game state. There you go. Let's run it, Dix. Let's run it. Okay, let's see if this game works. Might have some typos here and there. We're going to be called TF Dagger. I'm going to be Dick Sucker. Fuck it. With a Z, even. I want to fight. We have a baby goat. He's 15 health, right? Let's attack him first to make sure that still works. Okay, so he lost 6 health. Let's throw a dagger at him. I want to use a poison dagger. Yo, get him! Fuck him up! Okay. So, Dick chucks a poison dagger at Baby Goki. The dagger finds its mark. Uh-oh, Baby Goki rubs some sweat off its brow. Is damaged by the poison. Let's go. So I can just defend, right? He has 3 health now left, right? He should be dead now, I think, right? How is he still alive? Hey, he died. Let's go. So, he took how much poison damage, though? He's damaged. He's damaged. He's damaged. Oh, because he can die in his own turn now. Here's a problem. That's why he survived 3 turns, guys. Because, excuse me. Let's look at our code for the battle, right? We have this battle code here, do battle, right? Do battle only checks to see if we should end the battle or not after the monster's turn. Right, or just say before the player's turn, put it that way, before the player's turn it checks. So, we have to now assume that there are going to be times where the monster will be dead before its turn even starts. Right, before its turn even starts, it's going to die. So what we got to do, let's move the poison damage to the end of its turn. That'll fix it. Right? So right now we have this code right here for the monster's turn, take turn, right? When the turn starts, we reset his defending, right? He's no longer defending anymore. And then he takes poison damage. And then, whether he's alive or dead, we don't even check for that, he gets his turn. Right? So that's why he survived so long last time. Let's actually move the poison damage to the end of his turn, rather than the start of the turn. Yeah, let's do that, right? Well, here's a problem, right? What if the poison dagger would kill him before his turn starts? Let's actually change it to be this, right? We're gonna say if we'll say if self.hp is less than or equal to 0, then return. Right, so we're done. So if he's dead, then that's it. He died from the poison. Actually, I'm gonna make a little thing here. I'm gonna say here print self.monster type plus crossed its eyes and dropped dead, capital dead, from poison. Right, there you go. So now it can die from the poison, and it doesn't get a turn that way. So basically, return means end of this function, right? So we're saying here, if he's poisoned, then deal poison damage. And then if he's dead, then end this. Never get to this code, right? Never get to this part of the code, right? Don't get this far. Just end the function right here. If he's dead, right? If he's not dead, then keep on going and do this stuff here. Give him a turn, right? There. Now it should work. Now it should die properly, not get an extra turn. He should die. Definitely TF Dagger. He should definitely die. I low-key might start getting back into programming. It's kind of fun, right? Dick's like, why am I picking on a baby? Because we only have one monster type right now, dude. When we started today, right, we had more than one monster type. We've kind of reverted because we're kind of making things more object-oriented. I want to kind of make more monsters before the end of the stream. But we're kind of running out of time here. Let's do this test one more time. I'm going to be Dick Sucker again with an X this time. Classic Dicks. Fight. Okay, I want to hit him with the dagger right away. Item. Poison dagger. Oh, he's going to try the poison. Let's go. All right, so now he should have 12 health, right? Let's defend. Okay. Oh, right. It doesn't show his health. It only shows his health when I attack. Let's fix that code right now. So basically, if I attack, it prints off his health. Right? Why don't we print that off at the start of every round? Let's go out down here to our do battle function. And here is where the round starts. Right here. So let's move this code down to the start of every round. Like this. There we go. So now we can remove the HP notifications from the attack functions, because now every new round is going to show you the health. Let's go up here to our player's attack and remove this shit. We don't got to show the HP anymore. It's going to be shown automatically. And same with the other turn here, the other attack turn. Don't got to show the monster's health anymore because it's going to be shown automatically every round. There we go. Let's try this now. Run it. Okay, I'm going to be a TF dagger this time. I want to fight. Okay, so there's his health, right? So the baby Goki has 15 health and dagger has 25 health. I'm going to throw my dagger. There we go. That's updated automatically, right? Oh, I don't have it. Oh, I put an underscore there like a doofus. All right, let's go to items and use the poison space dagger. There we go. So now I took some damage, and now he's actually wounded, or he lost 3 health. Let's just defend now. He lost 3 more health. Okay, let's defend again. Okay, he lost 3 more health. Defend again. Yo, I got lucky as hell. He never attacked me once. Anyways, he's dead now. Boom. Yo. He crossed his eyes and dropped dead. There's supposed to be a space there. And dropped dead from the poison. Let's go. I'm victorious. Earned 5 gold. I'm now carrying 5 gold. Let's go fix that typo. So we have this monster here. He can be poisoned. And space. Dropped dead from the poison. Oh my god. That's dark. That's dark. Anyway, so now we have poison in our game. That's kind of cool. So now let's why don't we make more monster types? Let's talk about inheritance, guys. I thought we might not have time, but we do have a few more minutes left here. So basically, we make a new monster as of right now. We do it in do battle, right? It's a do battle function. It makes a monster, the old-fashioned way, by punching all these details as arguments to this, instantiation function, the init function, right, for monster. But let's talk about inheritance a little bit, right? So if I were to, let's say, make another kind of monster, let's say I wanted to make a baby Goki. Let's just do it the old-fashioned way, right? Before we knew how to do inheritance. Let's copy this, all this code, and then paste it right here. Maybe the follow TF Dagger. We do Python programming here every Friday. We also have a gameplay stream. We do a lot of gameplay here, like Hitman, Minecraft, Street Fighter, all kinds of crazy shit. Smash Brothers. But here on Fridays we do programming. And this time slot. So we have this new class. We're gonna call this a Baby Goki. Baby Goki monster. We'll call it Baby Goki. Who cares? We have a Baby Goki, right? And we can say, well, it's gonna have a monster type be Baby Goki, right? And it's going to have attack value of, I think we decided that was 6, was it? Let's see. He has an 8 attack, okay? He has 8 attack, 15 health. That's fine. So he has 8 attack. He has 15 health. His gold value is 5. Okay, so because we don't need these arguments anymore, we can get rid of all these arguments, right? Because we already know the monster type and the attack and the HP and the gold value. There you go. Right. And now we're good to go, right? Because Baby Goki's abilities, like take turn, this method, and attack, and taunt, and defend, those are all the same among any monsters. They don't change from monster to monster, right? So I can just leave those the same, right? That's cool. But we have a problem. Our problem is that we have all this fucking redundant code. It's exactly the same code as up here in monster, right? If I were to make another monster, let's make another monster. Let's go up here and copy paste Baby Goki again, right? Copy all this code here, paste it, right? I'm gonna make a adult Goki, right? Let's call him Goki, and he's gonna be called Goki. He has a lot more attack power, right? I think he has like how much attack power he's supposed to have. That's why I left this old function here. He has 15 attack, holy shit, and 20 health. So not much more health, but a lot more attack. Right. Thank you for the follow, Lily Hazel. Hope you're enjoying the stream so far. We'll be playing some more Hitman very soon here. He wrote 10 gold. Right. So again, here's our problem. For every class we've made, every monster we're making, we have a lot of the same code. Because it doesn't really matter which, if it's an adult or a baby Goki, they all have the same animations, animations, so the same string, same text for their attacks, for their poison damage. It's all the same for every monster, right? So why do we have to type the same code over and over again? Well, we don't. We can use inheritance. So the way inheritance works is it says, I'm making a new class called Baby Goki, but by default, it has everything that monster has, because it does, right? So monster up here, right, has all these cool things about it. It has all these attributes. It has all these methods like take turn and do attacks and that kind of thing. But Baby Goki is really only different from that in this part. Right? All the rest of the stuff is all the same. So why don't we just delete all that same stuff like this? Easy, hit the backspace button, boom. And instead say that our new class, Baby Goki, inherits everything from the monster class. Right? So now, Baby Goki gets everything that monster does. Right? There you go. Job's done. Let's go down here to Goki as well. And do the same thing. Goki inherits everything from monster. It does everything monster does. It has everything that monster has. And then delete all this other stuff we don't need. So what we're saying now is that although Goki has everything from monster, we want to override the method that's different. So although monster has its own init method right here, we are overriding that method. We are making our own version of init, right? Because that's different. So you can, when you inherit a class, you can selectively choose which things to override. And if you don't override them, then they're the same as they ever were. Right? Look how neat and tidy that is, right? That's another benefit of object-oriented programming. At first, last time we streamed this game, or this show, making new monsters could be kind of a pain in the ass, right? But now we can make hundreds of monsters, like rapidly. Let's make another one, right? Let's just make a dragon, right? Who cares? Watch this. Paste. Right here. Boom, boom. Class, dragon, inherits from monster. It does everything a monster can do, right? Its name is dragon, right? Its attack power is 20. It's really powerful. HP is 40, super powerful. It's worth, 50 gold. Boom. New monster is done. Now we have a dragon, right? Let's make a unicorn. Right, grab this, copy it, paste it. Unicorn, new class. Right? We're gonna call it unicorn. It's gonna have, 3 attack. It's not that much damage, but it's gonna have 100 health. Very hard to kill, but it is worth, 100 gold. Right? So it's very hard to kill. You have to survive for a very long time. It's gonna be doing 3 damage to you over and over again. It's gonna build up over time, right? As you try and do 100 damage to it. There you go. So now we have 4 monsters all of a sudden. Kind of sick. Right? They can all do the same thing monster can do. Now we can get a random monster. Let's go down here to our do battle code. Watch this shit. You guys are gonna flip when you see this. I guarantee it. Down here in our do battle code, right? It creates a monster for us, a Baby Goki. Previously it did that, right? However, now we have classes which themselves automatically manufacture an actual monster. So why don't we make a new monster list in the game state, right? A list of available monsters to us. Here's our game state. Let's make a new thing called a monster list, right? We'll call it available monsters. We'll say game state available monsters. We'll say monster types, right? Monster types. And we're gonna have all of our classes, right? It's gonna be a list. Excuse me, it has to be like this, actually. It's gonna be a list. We're gonna have, Baby Goki is one of our classes. We have Goki as a class. We have Dragon as a class. And we have Unicorn as a class, right? Those are all of our monster types. Boom. Easy, right? So now if we go up here to our do battle code for every new fight we do, we can say that our monster does not equal this. It equals something else. We're going to say here game state. We'll say random.choice. Game state monster types, right? And feed it the game state. I'm gonna say we'll make it simple. We'll call this a monster class. We'll say monster class equals random choice from our game state's monster types, right? Then we're gonna say the actual monster itself is our monster class. And we're going to feed it the game state as the argument, right? Because as you look at our monsters up here, like our dragons, right? They take a game state, right? The unicorn takes a game state. Goki takes a game state, right? All these things take the game state as their argument upon instantiation when you make them, right? So down here, we're saying we have this list of monster. I'm going to change this name to monster classes to be clear. These are all the classes, right? The Baby Goki class, the Goki class, the dragons, they're all molds, right? They're molds for making monsters. These are our monster classes. Let's go up here to our do battle code. And I'm saying get a random choice from our monster classes, right? So our monster class is going to be a random choice from our monster classes. And then our monster is going to be one of those monster molds. They're going to manufacture a new monster for us, right? So we're instantiating that mold. We're instantiating that class. We're making an object from that sort of structure, right? So we're gonna get back either a dragon or a unicorn or a baby Goki or a Goki now, right? And then battle will play out. So in 10 minutes, we have added a bunch of new monsters and we've made it random. Let's see what happens now. Looks like I got invalid syntax right here. Let's see, game state. Monster equals monster class game state. Oh, something right here. I see. I missed this closing parenthesis right there for that random.choice. Let's run it. Let's go. What's your name, son? I'll be Lily. I want to fight. Okay, so Goki's approaching, right? So we got a random draw. It was a Goki. That's not a really good draw. The best monster for us to fight at a low level, or at the start of the game, is a baby Goki. Let's hope for the best. I'm going to attack him right off the bat. Okay, he talks smack. So basically, there should be a space there. A little smack. Go up here to our monster code. Right. We have 4 monster types, right? But they all inherit from monster. They all behave the same way. Let's go up here to our actual monster code, like the deep monster code, and put a space right here. There you go. So now all monsters have that space fixed. Again, it's one of the benefits of object-oriented programming, right? They all inherit from this one class. So by fixing one line of code, I actually fix all the code. Nice. Okay, let's go back here to our game. Excuse me, to the actual running game. And now I got lucky there, right? So basically, they have a chance to taunt. They have a 1 in 3 chance to taunt, which is a waste of their turn. All right, so that's cool. He wasted his turn. Let's attack him again. Okay, he wasted his turn again. Awesome. I can kill him with a spear now. Here's our problem, guys. Lily does 6 damage. He has 8 health. The spear I have does double damage, but I can only use it once. I can kill him right now with a spear, but I'd lose my spear. Or I could take 2 turns to kill him. The thing is, if I kill him right now, then he won't be able to attack me back, right? Let's hope we get lucky. Let's attack him. Save the spear. Fuck, I got Tatsu. I shouldn't have waited. Oh well. Let's attack him one more time. Get the job done. I got 10 gold though. I can go to the shop and buy a potion. Let's go to the shop. I'm gonna buy a potion. I have 2 potions now. I can only use them in battle right now, though. I have to wait till the next fight to use them. I'm gonna have to. I'm very low on health. Let's do a fight. Oh, we got a unicorn. It's supposed to be a capital U for the unicorn, though. Let's go fix that right now. Oh, no, it doesn't really have to be a unicorn. Let's go up here and go to our unicorn code. And call this, because these are proper nouns, Baby Goki and Goki. Let's just say the dragon. The dragon is approaching. We'll say a dragon. Right? A dragon is approaching. No, we really can't. That's fine. We'll leave it the way it is right now. We'll call him Dragon, right? We'll call him, you know, Billy the Dragon. And we'll call this one Stacy the Unicorn. There you go. Problem solved. Easy peasy. Lemon squeezy. Because we have them be proper nouns at this point, right? To this point, they've always been proper nouns. Like Goki. Anyway, so, let's go here. The unicorn does 3 damage per attack, right? I'm not sure I can survive this. I almost certainly can't, right? Unless I get a lot of taunts. Let's use both of our potions right off the bat. Item. I'm going to use one of my potions. Boom. Then use another one. Item. Potion. Boom. Now I want to poison him, right? Item. Poison dagger. Oh, he tattooed me. It's alright. I only lost 3 health. What are you waiting for, Kenny? Yeah, the unicorn Tatsumaki's me. The unicorn Tatsu. Okay, let's throw my spear. I might as well. Okay, so at least it did full damage. Okay. So now I have to get very lucky, guys. I'm going to attack him constantly and hope that he dies before I do. Hopefully he does a lot of taunts. The protagonist starts with 5 gold, and when you kill Goku, you earn 10 gold. So your protagonist should have... No, it starts with 0 gold. Yeah, he starts with 0 gold power. He has no gold at start. I can go confirm that real quick. Go up here to our protagonist. He starts off with 0 gold. Okay, let's go here. Alright, so we have attack, defender, item. I'm going to just attack him, hope for the best. Alright, that's good. He's defending. I like that. He's taking poison damage as well. Nice. Yo, this might work, guys. Yo, I think I'm going to win. Yo, that poison's coming in. Thank you, TF Dagger, for that poison idea. That poison's coming in clutch right now. Alright. Yo. Oh my god. Yo, get 100 gold. 100 gold. Guys, we're set for life, dude. Let's go to the shop. I want to buy a potion. A shop. Go buy a potion. Shop. Go buy a potion. Shop. Definitely go buy a poison dagger. That came in really clutch. Shop. Go get another poison dagger. Shop. Go buy a spear. Shop. Go buy a spear. And shop. Go buy a potion. There we go. Now we're broke again. Sweet. But we have all kinds of cool stuff now to use. Let's go. So let's do another fight. Okay, we got another Goki. That's fine. So, I have a couple ways I can deal with the Goki, right? Well, I should heal. He can kill me in 1 hit. I should heal for sure. Let's do that first. He has 15 attack power. I have 15 health. We got a potion, a dagger, a spear, and a potion. Let's go with a potion. Oh, okay. So we attacked me. I have to heal again now. Okay. Let's item. Use a potion. Okay. So I can survive an attack now. Fuck Goki, man. I only need to use my spears and my daggers on Gokis, basically. No, the dragons are scary too. Dragons are very scary. Got some pretty bad luck here. He attacked us twice. No, he attacked us once so far, right? So if I throw a dagger, if I throw a spear, you can do 12 damage to him. I still have to attack him 2 more times. Let's just attack him then. Save the spear for the killing blow. Fuck! So I should have used a potion. Now he can kill me 1 hit anyway. I was so stupid. Right, so now if I use a potion, he can still kill me. He has 15 damage, and potions heal 10 HP. Yo, guys, cross your fingers. I'm gonna use one of my potions. Okay. I survived for now. Dude, I'm running low on potions. Man, fuck Goki, dude. Fuck a Goki. Okay, so I'm back to 25. I have no more potions. I bought all those potions and just used them all. against one fucking Goki. Yo, thank you, Dagger, for the $10, dude. That goes a long way in terms of buying food and that kind of thing. I appreciate it. I'm going to get some food for my Minecraft stream with that money. I appreciate that. I know it's a lot of money, too. Said I used to work minimum wage retail, and to me, $10 is like a huge amount of money. You have no idea how much that's going to help me out. Let's attack. Okay, I can kill him now with a spear, and I'm going to. If I don't, I risk losing, right? I don't want to lose any more health. Let's use an item. The spear does 12 damage. Boom. Okay, so now he's dead. I got 10 more gold. Let's go buy a potion, right? I'm glad, Dagger. I'm glad. Let's go to the shop. Buy the potion. Okay, so now we've got... how much health do we have? We still have 25, right? Let's go fight. There's another adult Goki. Okay. So I got a few options here. What if I were to throw a poison dagger at him? He would lose 3 health every turn. Would that save me a turn? Because Goki's so dangerous. That's half my attack power. I think that would save me a turn, right? Let's see, if I were to normally attack, I'd throw a dagger. That would do 3 damage on that turn. Let's just do it. I think that would work. Okay, he tatsued me. That's fine. So here's a benefit, right? I can actually heal this turn, and he still takes damage. That makes sense, right? Let's go to item. Use that potion I just bought. Okay, so I healed. He still took damage, right? Now I can attack him. No, if I throw the spear, he's gonna die. Let's do that, right? If I attack him, I'll do 6 damage. The poison will do 3 damage. He'll have 5 health left. If I throw the spear, though, it'll do 12 damage. He'll take 3 and he'll die. Let's do that. Use my spear. There you go, right? So he took the spear, no problem, he had 2 health left. Then he died from the poison. He dropped dead from the poison. 10 gold. All right, so let's go back to the shop. I have only 10 gold, though. But I need to buy another potion. Fuck, let's buy a potion. Okay, let's go fight. We have 1 dagger left and 1 potion left. It's a fucking unicorn. That's not a good look. Oh, but I have a poison dagger, don't I? Yo, let's go. Throw the dagger. All right, then fuck this man's up. Get him. Get him. Get him. He has to hit me 4 more times to kill me. Okay, let's do it. Yo, Mike, we have a shot, guys. We got a shot. Okay, here we go. He can't kill me yet. But I have to drink. I'll drink the potion right now. I have to drink it anyway before the fight's over. Okay. There we go. Here we got a lot of gold again, guys. We got so lucky right there. Let's go to the shop. Let's buy a lot of more potions. That was so lucky. Okay. Oops, I need to go fight, actually. I didn't mean to fight. I was supposed to... Oh, no! I meant shop! Yo, I'm gonna die with all this gold? I got 80 gold! Oh, my God. I typed in fight, I meant shop. No! It's okay. It was a good run. I got potions, right? I got a couple of them. Oh, my God. Yo, press that for your stacks. Thank you, Kenny. No, you son of a bitch. Damn. Shush. The dragon has slain Lily. Game over. We should make a Kamehameha indeed. Yeah, but I think it's the end of the stream, guys. So, we didn't get as far as I wanted to in terms of showing off the power of inheritance and objects. We still have a couple things here that are still kind of functional. But I think we kind of, I made my point, right? Objects are cool. They make the game a lot easier to add new stuff to. We added new features and stuff. Glad you enjoyed it, Dagger. It's a very fun language. If you guys want to learn more about Python, check out youtube.com/Vencabot archive, or just punch in Vencabot in the search bar on YouTube. You'll find me that way too. We have an entire series there called Intro to Python, where we have all 3 seasons now. Season 3 is almost done on YouTube as well, courtesy of this week's double upload schedule. But you can go learn about the basics, right? Today we kind of had more advanced concepts, but in 6 episodes I can teach you how to make a Pokemon game. I'll teach you how to make Zork, like a text-based adventure game, and then you can go watch this season from the start. where we talked about on day one, what is a function, what is a variable, how do they work, what's an argument, right? And gradually work your way up to this point, where you have a fully working game. This is the last episode of our season. Thank you, TF Dagger, again. You can't buy a large pizza for $10, so here's a little more. Thank you, dude. Then that goes a long way, man. I appreciate that. That's definitely, to me, a huge amount of scratch. The $20 will feed me for 2 days. So that's really awesome. Maybe even more than that. But, yeah, so you can go watch this project kind of develop over 6 episodes. This is the 6th episode here, the last episode. Next week, we'll do a new season. Start off with the very basics again, like what is a function, how to use Notepad to make Python scripts. As for the genre, maybe a dating sim. What do you guys think? Maybe something else. I don't know. We haven't decided yet. Something text-based and simple and kind of where we can teach about integers and stuff. Something with numbers involved. I kind of like RPGs for that reason. There's lots of numbers and stuff. But guys, I'm excited. I'm stammering. I'm excited for Hitman coming up next here. As usual, if you guys want to keep the channel online, check out my Patreon page, patreon.com/Vencabot. I stream for 40 hours a week every week. Thank you for the follow, Sir Wizard Lizard. I stream a lot, guys. I stream 5 nights a week, Monday through Friday. Mostly gameplay, lots of Street Fighter, some Smash Bros, a little bit of Minecraft, other games. But on Fridays, we always do Intro to Python from 6 to 9 p.m. Eastern. It's a series where I teach Python over 6 episodes for kind of like make a game start to finish, basically. This game is not really finished, but it's definitely playable and fun. I showed it's pretty fun. And it's a good beginner project. If you want to get the code for this, by the way, it's at github.com/Vencabot. That's github.com/Vencabot. It has all the code right there for you. Go learn how I did it. I'm going to go a very short break, guys. Come right back with some Hitman Blood Money. I will see you guys very shortly. Good game, gentlemen. Good games. If you're like me, you want to help the channel out, but you don't have a whole lot of money in your pocket, help for free in that case. Get in the chat, come say hi. Follow on Twitch, tell your friends we're here, spread the word, save clips of gameplay and stuff. You're going to see some of those very shortly here. Also, subscribe on YouTube at youtube.com/Vencabot Archive. We have so much footage there, it's crazy. We have more than 1,000 videos publicly available, mostly gameplay, some creative stuff like programming and music creation, that kind of stuff. We also have retro games, modern games, horror games, and shooting games, puzzle games, indie games, AAA games, fighting games, lots of Street Fighter. Again, as well as Python stuff on YouTube. If you're a member on Patreon, you have access to about 500 more videos. That's actually like the newer stuff that hasn't been published yet publicly. That's all on Patreon. In total, it's a lot of footage, guys. If it seems kind of overwhelming, keep in mind it's actually painstakingly organized by title in playlists for you. We have a playlist for the Intro to Python stuff, playlist for, Street Fighter, playlist for Sonic the Hedgehog. Tons of playlists, each one for their own game or show. You can go easily watch a lot more Intro to Python, if that pleases you, and learn Python on the quick. I find that, some courses for Python kind of don't treat the student with a whole lot of respect. They kind of move really, 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 really slow. And I feel like a lot of even total newbie programmers could learn things a lot faster. So our streams tend to kind of get through some ideas. I think in the course of a 6-episode stream, you can become pretty strong in Python. Let's put it that way.
The only thing that we can agree on is
Cody, what are you doing?
I'm glad you enjoyed it, Dagger.
That's what it is.
I love Python. My first language was, outside of basic, I learned JavaScript, then I learned Java, then I learned C++. After learning Python, man, it's a whole different ballpark. It's really a great language. I would never use another language now, to be honest, for pretty much anything, if I could help it. And it's also really friendly for novices. It's got a beautiful syntax that's easy to learn. Yeah, for real, Dagger, thank you, man. You're definitely a ballin' out here. Making my life easier as a streamer. Okay, when you stream 40 hours a week every week, you kind of need that scratch to make ends meet. I got you, Kenny. Enjoy your time at UFO, dude. Godspeed and have fun. Yes, pleasure by ladders. I don't know, Dix. If I could speak in Python, I probably would. English is okay, I guess.